Hi everyone. Let's start with this problem here. I'll send you its link in the chat. Okay, take 2 minutes to read it and think about it, and then we'll discuss it. Okay, I think the statement is small and straightforward. Let's read it. So, given two words, word 1 and word 2, find the minimum number of operations required to convert word 1 to word 2. So, we have three operations that we can operate. Insert a character, delete a character, or replace a character. We can do all of these operations on one word, okay, on word 1. So we cannot touch word 2, we can only touch word 1, and we're trying to convert it to word 2, okay. um, do anyone have any ideas or just a naive idea on how to make this conversion? Oh, so actually the answer should be the minimum number of operations, okay. So we can do one operation, or we can just ignore and don't do anything, okay. Someone wanted to talk?
Yeah, actually, what I understand, should I go for it?
Yeah, sure, go.
Yeah, basically, like there's a word two and word one. So always word two will be maybe lengthwise it will be equals, or it may be lesser. I mean, word one will be with higher length, word two will be with lower length, or it may be equal.
Well, we have delete character, so we can delete from word 1. So we can have smaller length or higher length, because you can delete and insert. So we can do anything in word 1. Are you getting that?
We can insert also. Okay.
Yeah. Okay.
Okay.
So the length of these two words doesn't matter. Okay. We can have an empty string and a string with just many characters, and we can just keep inserting to match.
Okay. We can break in character array and then we can try to compare it.
Hmm. Um, okay, yes, we'll do something like that. Okay, so I think this for this problem, uh, just a straight approach that comes to mind is DP, because we never know. Uh, so we have many operations, like three operations, and we want each character for each position to match that position in the next string. So we can try every possible way of doing such operations. So we can at each index try to delete or insert or replace. And so this suggests a DP approach, but I don't know, for this problem it doesn't. This is bad thing, but it didn't give us constraints on the length of word 1 and word 2. So that's why we'll try to make it as fast as possible. Okay, so we can do a DP like this. Okay. So let's say we'll start looking for the two strings. So let's say first that these two strings have at least one character. Okay. So we'll start looking at the first character for each two strings. Let's say we'll be looking for 0 and 0. Okay. And then I want to say that I want to make uh, the answer for 0 0 should be that I want to make the two characters at 0 and 0 in the two strings. So the character at 0 in the first string and the character at 0 in the second string, I want to make them identical, equal, right? So let's see what could we make applying these four operations. So we have four choices: either insert a character, or delete a character, or replace a character, or don't do anything. So let's say the first operation is don't do anything. So if we didn't do anything, that means that the character at index 0 and character at index 0 should be equal, right? So we will not do anything if and only if. So let's say this is I and this is j. So we will not do anything if and only if I equals to j. Okay, and then we will go to solve the next I and the next j. So we'll increase I plus 1 and j plus 1. Okay, let's say this is, we'll start our program with solve 0 0. Okay, so for the first choice, if the character at index I equals to the character at index j, then that means we don't need to make any changes here at I and j. Then we'll just go to the next index for them both. Okay, so let's look to the second choice. What if we wanted to insert a character? So let's see what happens if we inserted a character at position I. We are now standing at 0, for example. If we inserted a character at position I, what should happen? So what should happen is we will insert a character at position I that is equal to position j, right? Because remember, we want solve ij, we want at solve ij to have a string that matches at these two indices. Okay, so if we insert here, let's say here, so if we inserted, then I want to make the character at position I equals to the character at position j. But what happens here is that the length of word 1 will be increased by 1, right? Then let's simulate that. I have ABC and ADC, for example. Let's see, this is A. And I am now standing at 0 and 0, and I wanted to insert character at index 0. So what will happen here is, so let's say I will insert E, of course, because I want the character at index 0 here to be equal to the character at index 0 here. So if I inserted, then I'll insert E, and the length of word 1 will increase by 1. So how I will tell our solve function that this happened? I'll just I'll just increase I by 1. Okay, I'll just increase I by 1 and keep J as it is. So what I'll do here is I'll make this solve I plus 1 and then J. So yeah, let's see here. I was standing at 0 and 0, and when I inserted, then so when I inserted E, oh no, sorry, I made something wrong. So I'll increase J plus 1 and keep I as it is. Why? Because I inserted a character just before I here, and then I'll go looking for this I again with another index J. right? Because I made sure that j minus 1, so I made sure that j minus 1 equals to I. So do you understand this insert part? So again, if you didn't get it, I'm standing at, for example, 0 and 0 here. 0 and 0. And I want to insert at position 0. So what I'll insert is character equals to the character at j, which is 0. So I'll insert e here. And what I did here is that I increased the length of word by 1, but this will be simulated here as when I'm going to the next step, I will not increase I. So I will be the same as it is, and j will be increased by 1, because I just matched j minus 1. So I just matched j here with the inserted character. Okay, so this is concerned an operation, right? So the value of this operation will be 1. So I'll make 1 plus insert. Okay, let's look to the second operation, the third operation, which is delete. So when I delete a character, let's think again what will happen. So when I delete a character at position 0, for example, so here I deleted A. So what I did here is that I made I increased by 1, right? So I deleted A, then I increased by 1. So I'm now standing at 1, right? And then J doesn't affect anything. So nothing affected J. So when I deleted here A, for example, then I increased and became B. So what I did is that I increased and J became as it is. So the simulation of deleting a character will be 1 plus solve I plus 1 and J as it is. So this is the, okay. Uh, let's see about replace character. Okay. So let's see what will happen if I replaced the character. So again, I'm standing at 0, 0. And I want to replace, so remember that I'm doing every operation at I. So I'm just either deleting I or inserting at I or replacing at I. So if I replaced A, so for sure I replace it with the same character at J, right? So uh, if I replaced a character at I replace it with the same character at J. So A here, I replace it with E, of course. So when I replace a character, I'll increase I by 1 and J by 1, because I now finished applying matching on I and J. So I made I equals to J, and this operation costs 1, and then I will be increased by 1 because I'm going to look at the next character, and then J will be increased by 1 also because I'll go to look at the second character. Okay, so 1 plus solve I plus 1 J plus 1. Okay, so let's delete this and take a look on these four operations again. So first, do nothing. So do nothing, that means this will happen if and only if the characters at indices I and indices j are equal. So if they are equal, then I'll go to solve I plus 1, j plus 1. I'll go to the next characters. Okay. Second, insert. So if I inserted a character at index I, then I'll I inserted a character just before I, and then the word size increased by 1. Then I'll go to solve again with I and j plus 1 because I matched the inserted character with j. Okay, so I matched the inserted character with j, then I'll increase j, and I didn't affect. Okay, and with delete, I deleted the character at position I. Then for sure I'll go to I plus 1 because I is never in again. So I'll go to I plus 1 and try to match it with the same j. And for replacing, I'll I'll make sure that I replaced I with the same character at j. So that means that I no longer want to look at I and j, then I'll go to I plus 1 and j plus 1. Okay, so that will appear better in the solve function here. That will do it. So let's do the function before taking any input or anything. Let's just make a solve function here that returns the minimum number of operations required to match these two words. And so okay, first let's see what's the base case. So at the end, I want the whole word, the whole word 1 to be equal to the whole word 2. So that means that I finished matching every I with every j. So that means that I'm left with the last. So again, if I have here A, B, C, E, D, C. So if the word of size 1, if word 1 equals to 3, for example, and word 2 equals the size of it equals to 3, for example, then I know that I'm finished if I equals to 4. So if I am standing at 4, which is here, and j equals to 4, which is here. So if I'm looking at an index after the last index of the word 1 and an index after the last index of word 2, so that means that I finished matching all the before characters. Okay, so that's what it means, because I'm matching every pair. So I'm matching I with j until I reach I equals to n, so the size, and j equals to the size. Okay, so let's define here two integers n and m, which are the sizes corresponding to word 1 and word 2. And let's again make two strings here as s and t. So s, we want to convert s to t. So the base case would be if I equals to n, because we're standing, we're starting with 0 based in c's. Okay, and j equals to n. So now I've finished. Then I'll return 0. I'll do nothing again. Okay, let's go for our actual solving. So let's simulate these four operations. First, let's make result equals to some big number. Why some big number? Because I'll minimize it. I'll try to minimize it with either of these four operations. Okay. So first result will be equals to minimum between result, and then try this first operation. Or actually, I want to make an if condition first. So what's the condition here? So if s of I equals to t of j, then I'll do nothing, and then I'll go to I plus 1 and j plus 1. So here, if s of I equals to t of j, then I'll store in result the value of solve I plus 1, j plus 1. I'll not add 1 to this because I'm not doing any operation. Okay. But I want to make another check here. So before checking that s of I equals to t of j, I want also to check that I is more than n. So I is more than n and j is more than n. Because it can go, so at some point we can go to I equals to n and j equals to n minus 1. Because again, let's have the example here. So at some point I could reach I equals to 3, for example, looking here. And or no, let's say at some point I could reach I equals to 4, for example, and j equals to 3. And this could happen because I could, for example, insert some character at 4 here. So it could happen that I is not smaller than n, or j is not more than n. But it couldn't happen that I and j are greater than n and m. So we have here another case. So if I is greater than n or j is greater than m, then I'll just return 0. Or yeah, or just return some big number. Why some big number? Because if I reached this point, so that means that I reached a case, so I reached a point where I cannot make the first string equal to the second string. Okay. So here I simulated the first operation. Let's see the second operation. So I'll maximize the result with, if I wanted to insert, then I'll do 1 plus solve ij plus 1. Because I inserted a character at I, then I'll go to look with the same I, because I inserted a character before I. Then I'll go to look with the same I and j plus 1. So what about deleting? So result equals to max result and 1 plus solve. So if I deleted a character at I, plus 1j. So if I delete a character at I, then I'll go look for I plus 1 and the same j, because I didn't match I with anything with j. And if I replaced, then I go to match I plus 1 with j plus 1. Okay, that's it. And I'll just return a result. And of course, what I did now is just simple recursion. This is not DP. So I want to have memoization to make it DP. So let's say you have a memoization array, and it is, so this is just a 2D array, okay? So it's a vector of vectors, so a 2D array. Because it will not have an initial size, because I don't know the constraints here for this problem, so I'll not initialize this with anything. Instead, I'll resize the memo array with the sizes of word 1 and word 2. So that's why I made it a vector. I don't have to make it. So we now have memo array. So let's just make result equals to memo I and j. And if result equals to -1, then I didn't reach this state before. Okay. There's something wrong here. Okay, that's it. So let's check the function again. So our first base case is that if we reach the end, then I'll return 0. And if I reached I greater than n or j greater than m, then I'm out of bounds. Then I'll return very big value, because actually I want here to make this minimum. Why didn't you correct me? So I want the minimum number of operations, not maximum. Okay. So that's why I'm returning very big value if it's wrong, if I am at wrong state. The answer would just be minimum of any right value. Okay. And for sure, if the result equals to -1, then I couldn't just leave it as it is, because the minimum between everything will be -1. So I'll just have to initialize it again. It's 2a9. So let's initialize S and T and N and M. So we said that S equals toward 1 and T equals toward 2, N equals to S bit size, M equals to T bit size. And we want to resize memo. So memo is just a 2D array, so a vector of vectors, and the size of it should be n by m, right? So in C++, we can just call a resize function. Not memo dot resize. So here, okay, so here, let's remember how resize work. So memo dot resize, and just I'll set the size. So this is the size of the vector memo. But I want to say that each vector in each index, because it's vector of vectors, will be of size m minus 1. So this will be another vector int of size m plus 1. So that's how I'm resizing to the vector in C++. So for the first parameter here, I'm saying the size of memo. So its size, so it will have n plus 1 vectors. And for each vector, it will be a vector int of size n plus 1. Let's return solve 0, 0. And for sure, I'll return the answer to solve 0, 0. But first, I want to initialize everything at memo with -1, right? To make that, I'll add another parameter here. So here, the first parameter is the size, and the second parameter is the type, or not the type, so the actual value. So the actual value here is -1. Let's try to run. Okay, no errors. Okay, so ask me if anyone have any questions. I think you would have questions. Before I submit or do anything, anyone have questions? So everything is understood in this solve function? Everything is clear, right? Okay. Let's try one. Okay, so it matched right with an output 3. So let's try another example. And this should output 5. And it output 5. Okay, let's submit. Okay, accepted. So are you sure you have no questions in this code before I move on to our next problem? Everything is clear? Okay. So I sent you the code in the chat here.